Okay, hello everyone. Today we're looking at conditional probability. This should be Monday and Tuesday, okay? November 2nd and 3rd. The objective today, we're going to look at formulas. This is the formula up here for it. And it's conditional probability. We're going to use tables, these contingency tables that kind of look like this. And we're going to use these tree diagrams. You've kind of seen them before. And we'll look at those closer in the second video. The essential question: how can we find the probability of one event, given that another event has already occurred? All right, how can we measure the probability of some event, given that another event has already happened? Guys, think of these numbers right up here. Set A, 1 through 10. Okay? If I'm going to select two numbers out of this set right here, what's the probability that the second number that I select is less than 6 if the first number I select was odd? Okay, well look, it depends on what the first number that I picked was. I might have picked the 7 or the 9, but I might have picked the 3 or the 5. All right, so the probability of my second selection is affected by the first. All right, it's known as conditional probability. Here's the definition. You're going to need to know that. The probability of an event occurring based on a previous event already taken place. There's a formula that looks like this, and it reads like this: the probability of event B happening, given that event A has already happened. All right, and what it is the probability that they both happen divided by the probability that A happened by itself. Okay? Guys, we use tree diagrams and contingency tables to find the conditional probabilities, right, along with the formula. As tree diagrams, this is the definition. They represent a series of events with the probability of each event shown. They label each probability. And it shows a series of events, like a sequence of events, okay? And it kind of branches out like this, like a tree. Okay, this column right here is the conditional probability right here. And you notice we take the probability of the first one, of the first thing happening, times the conditional probability times to get the probability that they both happen. All right, and that's where the formula comes from, because we just divide it out. And we'll talk about that in the second video. Guys, contingency tables, they display data frequencies. That's what they do. The relative frequency is kind of like a probability. It's the frequency of the event divided by the possible outcomes. And here's some examples here, and we're going to go through a bunch of examples. But in this case, just the probability of freshmen, the total is 50 down here. There's 25 freshmen right here, okay? And the probability of cats, well, there's 22 cats. That's in this column here. The total number of cats is 22 divided by 50. But down here is conditional probability. It's a little different. You don't use this total down here. You don't use 50. All right, the sample space is constrained in conditional probability. All right, you can look back on this. We'll look at some examples. Again, this is cats. Given that they're freshmen, how many of them have cats? So given freshmen, that's 25. How many of those have cats? 13. This is given cats, how many of them are freshmen? All right, given cats is right here, 22. Of those 22, 13 freshmen have cats, all right? Here's another example. I take a look at this table. They're asking, what's the probability that a junior is selected? Well, here are the juniors right here. There's 40 juniors out of 115 total. Okay, so it looks like that. 40 over 115. That's the probability that's a junior, 35%. Now, what's the probability that a member of the art club selected at random is a junior? All right, that's a conditional probability. And we're not using the 115. All right, we are constricting the sample space to some subset of that sample space. All right, a member of the art club selected is a junior. So given that it's a member of the art club, that's 58 members of the art club, that's this column right here. How many of them are juniors? 16. So it's 28%. Think of this right here as kind of a fraction. The junior goes on top, the art goes on the bottom. Okay, the art is the bigger number. Look at the next one. What is the probability that a member of the drama club is selected? All right, that's not conditional. They just want to know what's the probability of picking someone from the drama club. Well, here's the column of drama club, 17. 17 total people in the drama club out of 115. All right, that's 15%. Now, what's the probability that a member of the drama club is a sophomore? All right, here's the drama club again, 17. Of those, 3 of them are sophomores. So we write it like that. Again, sophomore goes on top, drama goes on the bottom. It's not out of 115, it's only out of 17 that are in the drama club. Okay, I got 18%. All right, something similar. Guys, what's the probability that a sophomore is a member of the drama club? It's a little different. It's a different question, you guys, than D. D and E are 2 different questions. All right, one of them says, given that they're in the drama club, how many sophomores are there? This one down here is saying, given that they're a sophomore, how many are in the drama club? Right, the top number is the same, 3, but the bottom number is different. Right, sophomores. Out of sophomores, how many sophomores are there? There's 36. All right, you get 2 different answers here. All right, guys, that's it for this video. Go ahead and fill out the notes assignment and complete the summary. You should do okay with that. Again, come back in for the Zoom meeting. We'll do the vocabulary assessment together. The 4 vocabulary words are listed right there. All right, thanks.